Did you know that quasars, those enigmatic cosmic powerhouses, can outshine entire galaxies, packing the energy of billions of stars in a space smaller than our solar system? In this video, we will explore the origins of quasars and the cosmic world's mystery. Stick with me until the end of the video so you won't miss any exciting parts. The most fascinating questions in science, for example, what happens in black holes, how planets form, and where life comes from, are all tied to galaxies. In the universe's early days, only radiation and gases like hydrogen and helium existed. But it was within galaxies, where stars live, that the elements necessary for life were created. In many galaxies, a massive black hole at the center plays a significant role in how the rest of the galaxy grows and changes. So, if we want to understand the universe better, we need to understand the story of galaxies. First, let's see what a quasar is. So, it's the bright center of the galaxy. Scientists also call it a QSO, short for quasi-stellar object. The bright light comes from a supermassive black hole in the galaxy's center, which can be millions to even billions of times heavier than the Sun. Around this black hole, there's a swirling gas. As this gas falls into the black hole, it gets super hot and shoots out energy in the form of light. Quasars are incredibly powerful and brighter than entire galaxies like our Milky Way. They're basically a particular type of active galactic nucleus. The most intriguing part is that scientists use the term quasars because, when scientists first spotted them in the 1950s, they seemed like strange sources of radio waves that looked like stars in the sky. But when scientists looked closer with powerful telescopes like the Hubble Space Telescope, they discovered that quasars hang out at the centers of galaxies. Some of these galaxies are bumping into each other or merging. Just like people have different looks and personalities, quasars can vary greatly, too. Their appearance depends on things like how big the black hole is, how fast gas is getting sucked into it. Sometimes, other factors, like if there's a jet shooting out from the black hole or if the galaxy is hiding behind gas and dust, can change how a quasar looks. Did you know that astronomer John Bolton, from Britain and Australia, made some crucial discoveries about quasars back in the day, especially in 1962? This radio source, 3C273, was supposed to be hidden by the Moon 5 times. Two other scientists, Cyril Hazard and John Bolton, used a giant telescope called the Parkes Radio Telescope during one of these hiding times. It also helped another scientist named Martin Schmidt to find a visible version of the radio source and take a closer look at it with an even more giant telescope called the Hale telescope. When Martin Schmidt looked at the emission lines from 3C273, quasar, he saw something strange. They seemed like the spectral lines from hydrogen, but they were stretched out. It meant that 3C273 was moving away from us really fast. It was zooming away at about 47,000 kilometers per second. It was puzzling because nothing could explain why it was moving so quickly. The light from 3C273 was also really bright in radio waves. Even though it was far away, it was much brighter than any regular galaxy. Well, that means that even though it was small compared to a galaxy, it gave off a lot of light. Old pictures from the 1900s showed that 3C273 was shining brightly. And every year, it got brighter or dimmer. Most of its light came from a small area, much smaller than a galaxy. But when Martin Schmidt made his discovery, it completely changed how we looked at quasars. He discovered that the light from quasars was like regular light but stretched out, or redshifted, greatly. Soon after, scientists like Schmidt, Greenstein, and OK found similar things with different quasars. Even though everyone agreed on what they saw, they all didn't agree on what it meant. John Bolton thought the light was moving fast from faraway sources, but not everyone initially believed him. Before we move on to the next part of the video, subscribe to the channel so you don't miss exciting updates. Now, you must remember that quasars are super bright objects in space. Even though they appear dim from our planet, they are visible from very far away. The brightest one is 3C273, in the Virgo constellation. It does not look too bright in the sky, like a faint star, but it's mighty. If it were just 33 light-years away, it would shine almost as brightly as the Sun in our sky. This quasar gives off far more light than the Sun or even giant galaxies like the Milky Way. Scientists think these quasars shoot out energy in specific directions, like jets. Because there are so many galaxies, some energy jets are likely directed towards Earth. When a quasar's jet targets the Earth, it's even brighter. These extra bright ones are blazars. There's another super bright quasar called APMO 8279 plus 5255 that was discovered back in 1998. It's so bright that its absolute magnitude was measured at an astonishingly low number, -32.2. Here's the fascinating part: when scientists used powerful telescopes like the Hubble Space Telescope and the Keck Telescope, they found out that something was making it look even brighter than it actually was. It turned out that the quasar was being gravitationally lensed, which meant that something with a lot of mass, like a galaxy or a cluster of galaxies, was bending the light from the quasar as it traveled through space. This bending acted like a natural magnifying glass, making the quasar appear much brighter. Studies suggest that the light emitted by APMO 8279 plus 5255 has been magnified about 10 times due to this gravitational lensing. Even with this magnification, it's still way more luminous than other quasars nearby, including the famous 3C 273. Hyperluminous quasars like APMO 8279 plus 5255 are compelling and rare objects in the universe. They emit enormous amounts of energy, far more than regular quasars. This incredible brightness can be caused by various factors, such as the supermassive black hole at the center of the quasar gobbling up vast amounts of matter and releasing intense radiation. When these quasars are gravitationally lensed, they become even more intriguing to scientists because they offer a unique opportunity to study the effects of gravitational lensing and a better understanding of the properties of these extreme objects. It's fascinating, isn't it? Now, before moving toward the end of the video, let's see the most fascinating information about quasars. They are inspired by other active galaxies in many aspects. Their emissions can be compared to smaller active galaxies powered by smaller supermassive black holes. To shine as brightly as a typical quasar, a supermassive black hole would need to consume a massive amount of material, roughly equivalent to 10 times the mass of our Sun every year. The brightest quasars gulp even more, devouring about 1,000 times the mass of the Sun annually. The biggest known quasar eats up material equal to the mass of 10 Earths every second. Yes, every single second. The brightness of a quasar can change significantly over time, depending on its surroundings. Since it's hard to keep feeding a quasar for billions of years, it becomes an ordinary galaxy once it runs out of gas and dust to consume. Now, let's recall essential points from today's video. Quasars are super bright objects in the space. They share characteristics with other active galaxies like Seyfert, but they outshine them by consuming enormous amounts of material. Despite their immense power, quasars are not eternal. They turn into ordinary galaxies once they consume all the gas and dust in their environment. Their luminosities can vary over time, influenced by their surroundings. Studying quasars helps us understand these extreme objects and sheds light on the evolution of galaxies and the universe. Quasars stand as cosmic beacons, illuminating the mysteries of the cosmos. So, there you have it, guys. I hope you enjoyed watching this video. Share your thoughts or questions in the comment section.